All right, welcome back, everybody. Today we're going to finish up Chapter 3 and kind of bring things full circle for you in this chapter. Now, we start off talking about parallel and perpendicular lines. The last thing we talked about was equations of lines in a coordinate system. Today we're going to kind of bring those together and talk about equations of parallel and perpendicular lines in the coordinate system. Okay, specifically talking about the slopes of parallel and perpendicular lines. Objective to relate slopes of parallel and perpendicular lines. Let's get going with that. So starting with parallel lines, we'll say that if two non-vertical lines are parallel, then their slopes are equal. And also we could say the converse of that, if the slopes of two distinct non-vertical lines are equal, then the lines are parallel. Okay, so essentially parallel lines have the same slope. And we'll add to that any two vertical lines or horizontal lines are parallel as well. Okay, because we know that any two vertical lines have undefined slopes. We'll say that's the same, we'll say it's parallel. Same idea with any horizontal lines have slopes of 0. We'll say those are the same, those are parallel. Alright, so if we want to check and see if two lines are parallel to each other, what we're going to check is if they have the same slope. Okay, because if these lines have the same slope, their rise and run would be the same. They're going to go up by the same and over by the same, so they'll never catch each other, never run into each other. Okay, so problem 1 just says, are the lines shown in the graph parallel? And now come test time, come quiz time, I'm going to give you a picture where you can't necessarily tell just by looking at it. You're going to have to do the calculations. All right, so let's say that we have line 1 and line 2. We can find our slope, which the formula for that is equal to y2 minus y1 over x2 minus x1. Okay, so let's say I want to find the slope of the first line. We'll call that m sub 1. Okay, will be equal to y minus y. So it doesn't matter what order I go in. I'm just going to say negative 5 minus 3. All right, over in the same order, x minus x. So we'll say negative 3 minus 1. And what I'm going to end up with, negative 5 minus 3 would be a negative 8. All right, over negative 3 minus 1 would be a negative 4. Okay, negative 8 divided by negative 4 will give me a positive 2. All right, so the slope of my first line here is just a 2. Let's check and see if the second line has the same slope. We'll say m sub 2 is again equal to y minus y. So we'll go negative 2 minus 4 over x minus x, let's say 2 minus 5. All right, so we end up with a negative 6 over negative 3, which is a 2 as well. Okay, so we just show that these two lines have the same slope. Okay, rise of 2, run of 1. So we can say yes, they're parallel, okay, because they have the same slope. All right, again, so anytime you're checking if two lines are parallel to each other, find their slopes. If they're the same, they're parallel. If they're not, we'd say they're not parallel. All right, next thing we're going to do is write equations of parallel lines. So let's read through this and talk about what's going on. So problem 2 part A says, what's the equation of a line parallel to y equals negative 3x minus 5 that contains the point negative 1, 8? Write your answer in slope-intercept form. Now, I'm going to say this is just like some questions we did in the previous section where we write the equation of a line. Difference is when I say parallel to a given line, that's just a different way of telling you what I want the slope to be. Rather than giving you 2 points or telling you what the slope is, parallel to gives you the slope. Okay, so if I want it parallel to, like we said, it's going to have the same slope, meaning that my m, my slope for this equation, will just be a negative 3. All right, so we want to write the equation of a line through this point. Now, if we have the slope and a point, we've got to use our point-slope form, and that was the y minus y1 is equal to m times x minus x1 equation. Okay, filling that in, we have a y minus the y coordinate 8 is equal to the slope we just found, the negative 3, times x minus the x coordinate, so x minus negative 1, in other words, x plus 1. Okay, so there's an equation for the line I'm looking for, parallel to this line with the same slope through this point. Now, the trick is we want to write the answer in slope-intercept form. So, in other words, solve this equation for the y, get the y by itself, and then we'll have our y equals mx plus b form. Okay, again, just like we did in the last lesson. I'm going to distribute this negative 3 on the right. So we have the same thing on the left. Y minus 8 is equal to negative 3x minus 3. And then last step, we'll add 8 to both sides to give us a y equals negative 3x plus 5. All right, so that'd be my line parallel to the given line, same slopes, all right, through this point we were given here. All right, problem B is the same idea. Why don't you take a minute, pause the video, work through problem B, and then hit play to check your answer. All right, so part B, equation of a line parallel to y equals negative x minus 7 that contains this point. Okay, well that means that our slope is going to be the same slope as the line we're given. Okay, with the negative x we just say a negative 1. As far as our point slope form, we'll say y minus y1, which would be a 3, is equal to the negative 1 times x minus the x coordinate, so x plus 5. And again, we want that in slope-intercept form, so I'm going to distribute the 1 through on the right. That'll give me a y minus 3 is equal to negative x minus 5. And then we'll add 3 to both sides to leave us with y equals negative x minus 2. All right, so there's our equation parallel to the given line, negative 1 for our slope. Okay, through this point, solve down to slope-intercept form. Okay, so that's parallel lines. Next thing we'll talk about are perpendicular lines. And for that, I'm going to say that if two non-vertical lines are perpendicular, then their slopes are opposite reciprocals. And also the converse, if the slopes of two lines are opposite reciprocals, then the lines are perpendicular. Okay, so in other words, perpendicular lines have slopes that are opposite reciprocals to one another. Now, what do we mean by that? We mean that if one slope, we could say slope 1 is equal to a over b. Slope 2, the opposite reciprocal, would be a negative, okay, so flip the sign, b over a. Okay, so switch the sign, positive and negative or negative and positive, and then flip the fraction upside down, that's the reciprocal part. Okay, so specific example, we could say that if m1 is equal to negative 3/2, m2, then its opposite reciprocal would be a positive 2/3. Okay, having that opposite slope, okay, doing all these stuff backwards is what's going to make them have that right angle when they come together. Also, we could say that any horizontal line and vertical line are perpendicular. Okay, we can think of the zero slope and the undefined slope kind of like the opposite reciprocals to each other. Okay, so any vertical and horizontal line we'll say are perpendicular. So first thing we'll do with that is looking at determining whether or not two lines are perpendicular. So again, just like we did with parallel lines, are the lines shown on the graph perpendicular? And again, I'm going to give you a picture where you can't tell just by looking at it. You got to do the calculation. So let's find these two slopes. I'm going to say that this line right here is line 1. So m sub 1 is equal to y minus y. We can say 5 minus a negative 4, so 5 plus 4. All right, over x minus x in the same order, negative 2 minus 1. So in other words, we have a 9 over negative 3, which would give me a negative 3 for a slope. All right, and then for m2, this is our line 2, we have again y minus y, so we can say 1 minus 4. All right, in the same order, x minus x, negative 4 minus 2, which will leave us with a negative 3 on top over a negative 6 on the bottom. And that's going to reduce into a positive 1/2. Now, I'm going to say that these are not perpendicular lines, okay, because my two slopes are not opposite reciprocals, where the opposite reciprocal of negative 1 would be positive 1/3, okay, or the opposite reciprocal of 1/2 would be a negative 2. So they're kind of sort of close, but I'm going to say in this case, nope, not perpendicular. All right, so next let's work on writing equations of perpendicular lines. So similar to what we did with parallel lines, we want to know what's an equation of a line perpendicular to this guy right here that contains the point 15, negative 4. Again, right answer in slope-intercept form. Okay, difference here is with a perpendicular line, I'm going to look at the slope from the line, but my new slope is going to be the opposite reciprocal of that. So instead of 1/5, we'll flip that upside down, make it negative, and say my new slope is going to be a negative 5. And then from there, we'll do the same thing. We'll go to point slope form. So y minus the y coordinate of our point here, negative 4. So in other words, y plus 4 is equal to the perpendicular slope, the negative 5, times x minus the x coordinate. I have a little bit big numbers here, but we'll be all right. Okay, and then from there, we want the answer in slope-intercept form once again, so we'll solve this equation for y. I'm going to distribute my negative 5 through. So my pen glitches out on me there. Let's fix that arrow a little bit. There we go. So we'll have a y plus 4 is equal to negative 5x plus, for the negative times negative, and then 5 times 15 will be 75. And then last step, I'm going to subtract 4 from both sides. And we end up with y is equal to negative 5x plus 71. All right, so there's my perpendicular line with the opposite reciprocal slope of the line I'm given through this point in slope-intercept form. Okay, we've got one more for you, problem 4, part B. Now it works out a little different, same perpendicular slope idea, but it's asking for something a little different. Why don't you take a minute, pause the video, see if you can work through that, and then hit play to check your answer. All right, problem 4, same concept we're working with, perpendicular slopes, but this one's asking for us for a little bit different information. Okay, it's a little bit of problem-solving skills involved. It asks, what's the equation of a line perpendicular to the one shown with a y-intercept of 2? Okay, so I suppose if I want a line perpendicular to this one, first thing I need to figure out is what's its slope. All right, so we can say m is equal to y minus y. We can say negative 7 minus 3. All right, over in the same order, x minus x, negative 2 minus 2, which will give us a negative 10 over negative 4, which reduces down to a positive 5/2. So that's the slope of this line. The perpendicular slope then, I'm just going to call that the perp m, will be equal to the opposite reciprocal of that. That'll be a negative, because our original slope's positive, and then reciprocal, flip the fraction upside down, a negative 2/5. Okay, so there's the slope I want for my new line, and then here it flat out gives us the y-intercept. This is my b value, so I can just write it as y equals negative 2/5 x plus 2 the b in good old-fashioned y equals mx plus b form. All right, so there you go. That's it for the lesson, and that's actually it for the chapter, so we made it to the end. I guess moral of the story for 3.8 is parallel slopes are the same. perpendicular slopes are opposite reciprocals. Why don't you start cranking away at the homework, give it a shot, and like usual, if you need help, let us know. We're here to help you out.